Halo, perkenalkan saya Bintang Ramadan. Saya dari PT Land Railway System, berkedudukan di Bandung, Jawa Barat. Kami adalah salah satu anak perusahaan BUMN, yaitu PT Land Industri Persero yang saat ini menjadi holding perusahaan Defend ID. Tujuan utama kami mengikuti pameran ini yaitu agar kami bisa mendapatkan pasar baru. Dan kalau dilihat dari pengalaman-pengalaman sebelumnya, pameran ini juga memunculkan potensi-potensi supplier dan vendor yang dapat bekerja sama agar nantinya kami dapat mengembangkan sistem sendiri bekerja sama dengan partner-partner yang ada di Railway-Tech ini sendiri.
This is my first time to come to this exhibition, and I know this is the biggest railway exhibition in Indonesia. And it's my pleasure to attend this exhibition. And CRRC, as the biggest exhibitor in railway industry in Indonesia, we are very pleased to be invited to this exhibition. And we are the supplier of Jakarta-Bandung project. And now almost 90% of the project has already been finished. And we have already received many visitors from relevant industry, and also to supply the service and also the maintenance also.
Nama saya Dedi Irawan, saya Division Manager Motion Traction dari PT ABB Sakti Industri. ABB adalah perusahaan multinasional teknologi, worldwide company, bergerak di bidang elektrifikasi, automation, motion, dan robotics. Khusus untuk Railway Tech ini, kami memperkenalkan portfolio kami dari sisi traction, yaitu propulsi system. Karena kan di pameran ini berkumpul semua pemain-pemain kereta api. Jadi ini ajang yang betul-betul bagus. 3 hari ini sangat efektif, kita saling kenal semua, produk kita lebih dikenal, dan kami juga mengenal produk-produk yang lainnya juga, operator-operator kereta api di Indonesia.
Nama saya Restoiko Prabowo, kami dari PT Wijaya Karya Beton Tbk. Kami adalah industri manufaktur yang bergerak di bidang engineering, procurement, and instalasi. Untuk pasar kita adalah di bagian manufaktur. Untuk di industri Indonesia yaitu kita suplai beton pracetak. Tujuan kami yang utama yaitu memperkenalkan Wika Beton di industri perkeretaapian di Indonesia. Yang sebelumnya kita sudah ada pengalaman dan kita ingin menunjukkan lagi di dunia transportasi ini.
My name is Amir Junaidi. I'm the International Sales Director of the company TrackTech and Management Board member. Company TrackTech is a Polish-German company producing in the railway business railway turnouts, as well as concrete sleepers and wooden sleepers, as well as fastening. Our production facilities are located in Poland, 6, as well as in Germany. And our intention is to do international sales. We serve transit authorities and railway organizations worldwide. We sell today to more than 40 countries, from very west, from Vancouver, Canada, to Asia. We have references in Malaysia, in Philippines, and from the very north of Sweden up to south to Africa. And we know how important the Indonesian market is, which is very much growing. We see the potential and the big railway projects that are in the pipeline, and we are very eager to step into this market. Our intention is very important for us, meeting all potential customers. We had the chance to speak to construction companies who are building these railway lines, as well as potential partners with whom we can set up cooperations. So this exhibition is very valuable for us.
Good afternoon, ladies and gentlemen. I would like to welcome all speakers and attendees who join us at Indonesia Railway Virtual Conference 2023, held by Indonesia Railway Society or MASCA and GAME Indonesia. Indonesia Railway Virtual Conference is held to support Railway Tech Indonesia 2023, an event featuring railway technology, equipment, systems, and services. And please be informed that all together with the exhibition of Railway Tech Indonesia, we will hold Indonesia Railway Conference 2023 at Jakarta International Expo. This conference will be hosted by MASCA and strongly supported by Indonesia Ministry of Transportation. Please take note on the schedule of Railway Tech Indonesia 2023, which will be held from 23rd to 25th of August 2023. Railway Tech Indonesia is an international B2B and B2G railway event to support Indonesian railway projects. This show has proven to be the most effective way to build a quality network with Indonesian railway professionals, because all the main Indonesian railway important people will attend and have discussions during exhibition and conference. Ladies and gentlemen, today we are honored with the presence of Mr. Joko Murdiono as the representative of Mr. Rizal Wasal, Director General of Railways, the Ministry of Transportation, Republic of Indonesia, and Mr. Hermanto Dwiatmoko, the Chairman of MASCA. And now, let us welcome Mr. Hermanto Dwiatmoko to deliver an opening remark for today's webinar. Silahkan Pak Hermanto. Suaranya boleh dibuka Pak Hermanto?
Ya, thank you Mr. Yun. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Director General of Railways, who is in this case be represented by Secretary General of Railway, Director General of Railway, Bapak Joko Murdiono, speakers and participants of this webinar. First of all, let us offer our praise and gratitude to Allah Subhanahu wa Ta'ala, who has given His guidance to all of us so that we can meet at the very important event this afternoon. Namely, the webinar organized by Indonesian Railway Society or MASCA, where the topic today is Indonesian Railway Safety. On behalf of the Indonesian Railway Safety Society, I welcome to all the speakers, especially our guest from Istako, Mr. Ali Farahani, and all the participants in this webinar. Besides that, I also would like to thank the speaker who have taken their time so that on today they can give presentation on the topic of railway safety. We know that railway safety is the spearhead of the rail transportation operation and services, because whatever we do, it is not safe, it is of course is useless. Therefore, at this afternoon today, MASCA is holding the webinar with the topic that we can contribute in the railways in Indonesia. Finally, by saying Bismillahirrahmanirrahim, I hereby officially open this webinar and hopefully it can contribute to railways in Indonesia, especially in improving the railway safety. That is all, and thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Pak Hermanto. Next, let us welcome Mr. Joko Murdiono, Secretary of the Directorate General of Railways, the Ministry of Transportation, Republic of Indonesia. He is representing Mr. Rizal Wasal, Director General of Railways, as the keynote speaker today. Selamat siang Pak Joko, silahkan. Pak Joko, silahkan membuka videonya. Pak Joko. Nampaknya ada kendala. Sembari menunggu Pak Joko, mungkin kita bisa maju terlebih dahulu. Pak Krisna, mungkin kita bisa melanjutkan untuk bedah buku.
Okay.
Setelah Pak Joko kembali, nanti kita akan meminta beliau.
Yeah, no problem.
Baik, Pak.
Okay, thank you very much, Bu Liyun. So I was actually the one who checked the team of Pak Joko. They promised us to be around at 13:30 today, but I think there is a constraint. Maybe he's having another meeting. We'll just wait for him to show up here. And we'll move to the session of discussion by the opening part of it, that is the book review, will be presented by Pak Hermanto. For those who just know him, I would like to introduce him. He is the former Director General of Railway and now as a chairman of MASCA, as well as the chairman of Indonesian Engineer Association or Institution, chapter railway. He has a very long experience in railway system in Indonesia. He used to be some directors, and not only one director of infrastructure, director of rolling stock, director of safety in the Director General of Railway. And Pak Hermanto graduated from ITB for his bachelor and masters, both of them from ITB, and got his doctorate from Pajajaran University. He was born in Surabaya back in 1956 and just have his birthday some months ago. Pak Hermanto, please entertain us with your presentations. You have 24 minutes. Maybe you can make it more if you need it. Nobody would like to stop you because you're going to present the very interesting part of this session. Please, Pak Hermanto, silakan Pak. Monggo.
Okay, thank you very much, Pak Krishna. So, this opportunity, I would like to with information that this is my last book. The title is Indonesian Railway Safety. Yeah, I would like to start. These books, I wrote this in last year. And then I already received the copyright from government of Indonesia. And then, so the purpose of the books, there are still limited books on railways, especially related to the railway safety in Indonesia. This book can be used as a textbook for lecturers at the universities. Thirdly, as a means for the public to gain knowledge about the feasibility of train operating facilities. It is a contribution from the Indonesian Railway Society to provide railway safety socialization. Introduction. Railway transportation in Indonesia in the last 5 years has became a concern for the government of Indonesia by rehabilitating railway lines, developing of the double tracks, and new railway lines. although railway safety has increased, train accident still occur. So it requires effort to improve safety through improving the visibility of infrastructure and rolling stock, as well as the competence of railway human resources. You can see here that the railway network in Java, Sumatra, and Sulawesi is about 8,000, but operation only 6,000, but more than 6,000. The number of the accident in the 5 years, about 130, consists of collision between trains, 1, and then derailment 126, roll, 1, and wood or landslide 0, and then others collision is 2. And then also the number of victim in the 5 years is about 415. Is death is 132, and then serious injury 124, and minor injury 159. If we see both the causes, first is for the causes from rolling stock is about 30, and then from the tracks 68, and then from human resources 14, external 9, and natural 1. This means that all total 122 for 6 years, from 2015 to 2020. If we analyze the train accidents, we have at least 3 main causes. First is collision between trains, and then second is the derailments, and third is accident at the level crossing. First, regarding the collision between trains, we remember that in 1987, but this is the biggest accident in Indonesia, in Bintaro, that one, with the death is 139 deaths and 254 serious injuries. And then also accident at the Gubuk station in 2006 between train number 150 Kertajaya and train number 4 Sembrani. And then also the biggest is accident at the Petarukan station, 2010, with 35 people died and 29 people injuries. According to the National Safety Committee or KNKT, the cause of the accident is first is negligence of the train crew or driver for violating the signal that should have stopped. Second is the train cannot stop because the rolling stock is unfit and difficult for the driver to stop. Third is the signal does not work well and is not visible to the drivers, resulting in delay in reducing the speed of the train by the driver. Drivers are not considered and sometimes sleep, so they cannot carry out their duties properly. And then the train stop at the station, but it's not free yet, so the free space is not filled. About derailment, you can see in this figure that how the process of derailment from the beginning after the derail in condition. What is the derailment causes? First is defect in the rails. Rails bend due to the high temperature pressure, widening of the gauge, defect in axles, stuck bearings, broken spring, broken spring and or suspension components. Second is longitudinal forces acting along the circuit or sudden braking can cause the wheels to rise and then fall. A train that running and gets a shock, then rear carriage can lift. Third is rolling stock coupler is assembled, loose and overrides with each other due to the lack of the fixability. Fourth is a long shunting that passes through the sharp curve, and then error placing of the load and shifting the load when the train is running, and then the train runs over the maximum speed or over speed. This is the forces that be done in the rail and wheel and rails. The railman, this is be good for the railman. This in Java and Sumatra last time. About level crossing accident. Some of level crossing done in the some of the crossing in Java and also Sumatra. And we can see that the number of level crossing is increased and sometimes decrease. Now about 5,000 level crossing. And then how to improve the railway safety. If you can see this in the transportation safety, there are some factors. First is human resources. Second is operation and maintenance. Third is regulation. Fourth is environment. Fifth is natural disaster. Sixth is worthiness, and then inspection and also technology. So that is the element of or variable in the transport safety. So about the worthiness. So this is the process how to increase the worthiness from the regulator. They have to get the first testing, and then operator must make a maintenance or operation, and then the regulator again to work the periodic testing, inspection, and also the audit. How about the railway worthiness? First is meets the technical specification, and then second is pass the first test and a periodic test. Third is maintenance has been carried out according to the procedure. Fourth is inspection has been carried out by the procedure. Fifth is operated according to the applicable procedures. And lastly, operated has tested, maintained, inspected, and also audited by competent personnel. So finally, some summary I would like to share about the summary. First, even though the training accident will still occur in Indonesia, they are decreasing. Efforts need to be made so that safety can be further improved. Second, various events have been and will be carried out by the government of Indonesia and train operators to improve safety, including through testing, inspection, maintenance, and improvement of human resources competence. Third is to reduce train accidents at the level crossing. It has been programmed to gradually build flyovers or underpasses, as well as socialization to improve community discipline when crossing the level crossing. That's all my presentation. Thank you very much, Pak President.
All right. Thank you, Pak Hermanto. Pak Joko ada di sini, boleh buka kameranya? Baik.
Let me take some conclusion first for Pak Hermanto's presentation, Bu Liun.
Oh, okay.
Okay, yeah, because I have to close this sub-session of this. Firstly, I forgot to mention to the audience that Pak Hermanto has already written so many books. I think 7 or 8 books. I forgot some of them. I was the
14,
editor.
Pak.
Yeah,
14.
14 books already regarding railways. So, yeah, for those who wants to get the book from Hermanto, you can just simply have a contact with Maska. And regarding this book, it was actually before written in Bahasa Indonesia, ya Pak Hermanto, ya?
Yeah.
And now it is written in English, so to make it more understandable to other people, not only by Indonesians. And regarding the content of this book, I would like to take some conclusions that accidents happen because of the two big factors, which are human and equipment failure. And in other terms, we usually, because I already worked with Pak Hermanto for more than 15 years, we name it cultural factor and instrumental factor. Cultural factors end up with disobedience, ketidakpatuhan pada aturan main, and failure end up with, of course, what do you call this? Yeah, accident itself. Jadi kalau ada kegagalan, I have to mix my language in bahasa Indonesia and in English because most of the Indonesia itu bisa terjadi karena regulasi, bisa terjadi karena peralatan yang kurang mumpuni. And Pak Hermanto, there are so many questions about how to get this book. Did I convey it right? That they can contact Maska to get the book?
Yeah.
Okay. Yeah, maybe later we will give the address how to get the book. Pak Hermanto, thank you very much. Terima kasih banyak for the presentations. It's really enlightened us with the concepts and principles of railway safety in Indonesia. This is a must-read book for us who have interest in railway safety. Now I turn it back to Bu Liun. If you want to contact Pak Joko, please, Bu Liun.
Ya, terima kasih Pak Krisna. Next, let us welcome Mr. Joko Murdiono, Secretary of the Directorate General of Railways, the Ministry of Transportation, Republic of Indonesia. He is representing Mr. Rizal Wasal, Director General of Railways, as the keynote speaker today. Silahkan Pak Joko.
Baik, terima kasih Ibu. Thank you. Chairman of MASCA, Indonesia Railway Society, Mr. Hermanto Triatmoko, distinguished guests, ladies and gentlemen, good afternoon. First of all, on behalf of the government of Indonesia, allow me to express my appreciation to Chairman of MASCA, Indonesia Railway Society, for holding Indonesia Railway Society Safety today. It's a great honor and privilege for me to have a few words on this precious forum. Ladies and gentlemen, railways as a model of transportation in the existing national transportation system would transport characteristic and on advantage. Trains can spread from other modes of transport. Therefore, needs to be developed and improve its role as a regional relation, both national and internationally, to support, encourage, and driving national development improve people's welfare. Railways organize to facilitate movement of people and or goods in both safely, securely, comfortably, quickly, precisely, orderly, organized, and efficient. Safety is very classic slogan with famous transportation services business, including railways. Implicitly, it shows that safety is expected by every transportation user. Ladies and gentlemen, railway safety are still an issue raised in the National Planning and Planning Document, or RPJMN and Renstra. train accidents are still dominated by the train incident, which illustrate the inadequate condition of the railways. Railway safety policy is directed at strengthening institutional rules, increase the safety feasibility of rolling stock and railway infrastructure, and increasing the capacity of human resource to support safety performance. Railway safety improvement is carried out through the provision of rolling stock and railway infrastructure that meets eligibility. To guarantee the condition of the railway infrastructure, the need for infrastructure maintenance must be met, while the safety level of rolling stock is met through the provision of a train flat with an operational age. The government role in ensuring that railway service are safe, secure, comfortable, fast, and on time is through, such as one regulation or railroad regulation, second control or certification and accreditation, third supervision or inspection, audit, and assessment. Ladies and gentlemen, several railway safety issues that need attention and must be resolved immediately include as regulation safety and security, or for example, new railways technology, vandalism, and terrorism. Second, operator complaints, or for example, the implementation of railway safety management system is not yet comprehensive. The competence and accreditation, or for example, competence for new railway technology and regulator human resources. Level crossing, or there is still a high number of accident of level crossing. Ladies and gentlemen, railway transportation safety has a strategic value which, if it is not developed with priority, can invite negative impact. Standard rail transport operation safety aim to hazard and risk identification, ensure accident can be controlled, ensure the integration of various operators can set and regulate it, ensure the safety and health of passenger, workers, and society, and guarantee that no property damage occurs. Ladies and gentlemen, lastly, I would like to say that it is delightful for me to join this important forum. I hope we can have a broader vision about railway safety from this forum, which we can implement in Indonesia. Thank you for your attention. Ucapkan terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih banyak Pak Joko Murdiono. Now we like to take a moment to get a picture with the whole speakers. Pak Hermanto, Pak Joko Murdiono, Pak Bakili, and the moderator. All right. Now please take position and be ready. All right, 1, 2, 3. Thank you, everyone. Now, if I may have your attention, please, I would like to show one video to all of you. Operator? right, ladies and gentlemen, thank you for staying with us. We have some announcements for you, please. For all speakers, would you all please turn on your camera? If you need to leave for a while, just keep your camera on. Okay, then for all the attendees, if you have any question to the speakers, please write down on chat or question column. We will answer them during Q&A session. And for attendees who need the certificates, we will inform the link at the chat column during Q&A session. Please access the link and fill in the needed information. Saya ulangi, bagi para audiens yang membutuhkan sertifikat keikutsertaan dan materi presentasi dari virtual conference ini, Anda akan diberikan kesempatan untuk mengakses link pada kolom chat di sesi tanya jawab. Silahkan memeriksa pesan yang akan kami sampaikan. Alright, now let us welcome back again for our moderator, Bapak Krishna Amir Hamzah from Indonesia Railway Society. Silahkan Pak Krishna untuk memulai sesinya kembali. Silahkan Bapak suaranya. Mikrofonnya.
I have to unmute my microphone. Is it okay now? Can you hear me?
Yeah. Yeah.
Okay. Thank you very much, Leon. Before I move to the next session, I would like to express my gratitude to Pak Joko, the Sesdijen of Director General of Railway, for representing the government, giving the support for us to improve the railway safety system in Indonesia. And next, we will be represented again by Ibu Erni Basi, the Director of Railway Safety. Pak Joko have already mentioned some crucial matters to be scrutinized in our program to increase the level of safety in Indonesia. And mostly we have to avoid both the incidents and the accidents. So Bu Erni, I think will elaborate with us more programs that are going to be implemented in Indonesia. But before that, I would like to introduce you Bu Erni first. He was born in Belopa. I was Googling before, where is Belopa? I thought it was in Spain, close to Belanova or something. But it turned out it was in South Sulawesi, Bu Erni, yeah? He was born back in 1976 there. Belopa, I just know it is the capital city of Luwu, Kabupaten Luwu. Bu Erni finished his undergraduate in University of Diponegoro and then got his master from Hiroshima University. Bu Erni sudah siap, Bu?
Siap.
Okay, please entertain us with the explanation. The screen is now yours.
Okay.
Silakan.
Thank you very much, ladies and gentlemen. Thank you for having me. Today, I would like to introduce you about our performance and then how our role in as a regulator. My agenda, I have a 4 part. One of policy, safety management system, railway incident. I think this is already mentioned by Mr. Hermanto. There are so many challenges of railway incidents, but we have confidence for future Indonesian railway. So also many issues you can find here. Actually, you know, this is picture. You see MRT. MRT is a highlights car-free urban transportation is a very nice performance. And so this is still zero accident. This is good for us as a 4 years introduction urban. And then, you know, we have legal basis. I think existing or urban railways change regulation signed 2007. And then we have milestones, so many part of railway law, as you know, we have part of traffic transport, infrastructure, rolling stock, human resource, safety, and then others. I think very important we should know about human resource is very, very important. How we manage by the law, and then also safety, how we maintain our infrastructures and rolling stock is it is a very mixing, and then so that's why we need to impact traffic and transport high demand. And then also Mr. Doko almost said it's a national railway master plan. And then next this year we have a high-speed railway. As you know, we still preparing the operation. It's very, very interesting for Indonesia. So, government rules, we have a regulation, as I mentioned, and then also we have finishing our constructions, we have control within the certifications, such as railway personnel, rolling stock, and infrastructures. Also, we have accreditations, railway academy, and then testing body. And then very, very important in my part, we have supervisions, inspections, audit, and safety assessment. This is our basis. We have a quality management system using SNE or ISO 19001-2000 last year's. It's the highlights for us to better performance for next futures. And then, actually governments have a long medium-term strategy to prioritize the safety and security in transportations, not only for railway, but also all of the transportations. I think safety and security very, very important because priority already mentioned, and then we have we have a strategic plan for the documents. As you know, we have activity target, development, improvement of railway connectivity policy, increase connectivity railway network, and then, we have a service, improve performance of railway traffic transport service, increase infrastructure capacity to support railway service. So for the safety, we have improved reliability of railway infrastructures, improved reliability of railway rolling stock, and increasing safety in the implementation of railway. As I mentioned, we have urban transportation operator like MRT, Jakarta, Jakpro, and then coming months we have LRT Jabodebek or KT high-speed train. This is, we have a target to develop our strategy, so including safety. Actually, our program in connectivity railway infrastructures, we have improved our service, and then our KPI, we need to remove for zero incidents. But actually, we have a process to improve that. So, we have developed some of in government, we have a department, you see here so many colors. Actually, our safety, you see in this color for safety technical recommendation. In the planning stage, we have a business process. It's very, very important because safety from the pre-design to construction and designs, we have a role to recommend the safety technical and safety monitoring evaluation, and then safety technical recommendations. Very, very completed to to establish our infrastructures. Also, in the railway safety management system, we have certificate and recommendation railway safety management. So after we build the infrastructure, we conduct some safety assessment for each of component of the infrastructure. So we can institute certifications of infrastructures, maintenance, inspection, or operation personnel. So it is very important. Also, we have access to verify our personnel, not only for regulator, but also our operator. So this is challenge for us because, you know, we have next for operator for high-speed train, we have so many human resource, new human resource is challenging. So about the post-construction, we also have some conduct safety inspection or audit, law enforcement, emergency response, accidents analysis, then examinations, and safety management. This is for infrastructures. Actually, we have also here about the rolling stock from design, construction, and post-construction. Our role in safety have same process as we mentioned. We issued some recommendation, technical safety, and then safety monitoring and evaluation during the constructions. I think the stepping is the same, not different within the infrastructure and rolling stock. I think for basic safety principle, I think everybody know how the road cause of accidents, but actually we have a pie mapping here from policy. Number one, in the second is safety planning, and then C is safety planning implementation. 4 is safety performance monitoring, and the last is performance review and improvement. Actually, this is standards I already mentioned before in the main mapping of processing infrastructure and rolling stocks. So we have so many challenges how we control our safety planning implementation. We have as I see here, monitoring standard, potential hazard and accident reporting, collecting and use of data, railway SMS. I think many complex, but in Indonesia, role is safety is international issue. I think is the same because we using a standard international also. But in I want to show you, we in Indonesia, we have safety management system integration, railway safety, SMKP from Directorate General of Railway, but also we have from Minister Regulation Public Works, so also occupational safety. So there are 3 main department or minister very concerned about safety management to integrate it to realizing of occupational safety and health, construction engineering safety, public safety, environmental safety, and railway operation safety. As I mentioned, safety assessments is our conduct. If this is, you see here, hierarchy, how we eliminate, but risk is still a concern every step of our processing here, coming from government regulation number 9 year 2017. So actually railway accidents, same with Mr. Hermanto mentioned in the book, very I think the book is very important. You can read it so we can thank you very much for Mr. Hermanto. You have a very important to public show the book. So we waiting to see in detail your books. Thank you very much. I think the data is we can come from is saying that everybody concerns to mention in this year's eliminate the accidents, I hope. Actually, the last my presentations safety issues is about security regulation. So many we have railway technology. You know we have MRT, LRT, sky trains. This is a technology. Maybe next presentation can explain how technology very important in the industry. So actually we already operate, and then I hope academic and industry still conduct to elaborate and all together. Sorry. But together for safety regulation. So sorry, operator complaints. So we have a transition and audit the system from 2008. You see here there are railway accidents high in last years, still under constructions, and also a commuter railway is derailment. Actually, the competence and accelerations we still standardize. Some of we using the standardized for competent for new railway technology, and then manufacturing competent standard, and then we still have a lack regulator human resource. So we have a gap between industry and then provided the human resource. We still need more assessor, inspector, auditor, examiner, or investigator in this coming years. This is our challenge. And then also we have a need organization or body institution in the railway like infrastructure, academy, or testing body. So I think this is my last presentation. Thank you very much for all of you, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Bu Director. Well, your presentations give us more confidence to have a better expectation about railway safety in the next future. You presented some complete aspect of railway safety being scrutinized by the government. I can see, of course, you have some problem with your throat. It's reflecting that you've been working very hard. Ya, kalau orang sakit tenggorokan itu artinya bekerja keras sekali. Mudah-mudahan dengan Ibu bekerja keras, peningkatan dari safety ini terus tercapai. And I would like to give a comment about the material of the presentation. I think it's very much in line with the books of Pak Hermanto. So it is really completing the book, Bu Erni. So I think the combinations of the book written by Pak Hermanto and your presentations are both must-read things for the Indonesian railway activities. I think that is it. And yeah, I believe you're doing so many safety assessments. I think maybe including to the equipments. Kalau equipments di Ibu juga bukan safety-nya, assessment-nya, atau you did assessment only for the installed equipments? Are you also giving certification for the equipments, for the new equipments, for example, Bernie?
Oh, we just have a rolling stock, but equipment still maybe another department.
Oh, this is in infrastructure.
Infrastructure.
Directorate. Okay. Okay. Only for rolling stock in your directorate.
Mm.
Okay. Yeah, because Pak Hari Samsudin was waiting for this question to be answered. Is he going to see your office or another office? And then also, yeah, it is very interesting that you have a very complete and complex safety planning and monitoring system. I hope you success, Bu Erni. Please stay. There will be a question and answer sessions. So many questions have been raised for you. I just hold it later. We will move to the next speaker, Pak Zulham.
Interupsi,
Yes.
Pak Krishna. I would like to show one video to the attendees,
Okay.
please.
Yeah, okay. It's your authority.
Yeah.
Okay, let's just enjoy
Thank you, Pak.
the video.
Silakan,
Silakan.
operator. Suaranya.
Halo, perkenalkan saya Bintang Ramadan. Saya dari PT Land Railway System, berkedudukan di Bandung, Jawa Barat. Kami adalah salah satu anak perusahaan BUMN, yaitu PT Land Industri Persero yang saat ini menjadi holding perusahaan Defend ID. Tujuan utama kami mengikuti pameran ini yaitu agar kami bisa mendapatkan pasar baru. Dan kalau dilihat dari pengalaman-pengalaman sebelumnya, pameran ini juga memunculkan potensi-potensi supplier dan vendor yang dapat bekerja sama agar nantinya kami dapat mengembangkan sistem sendiri bekerja sama dengan partner-partner yang ada di Railway ini sendiri. Dampak positif setelah mengikuti pameran ini, khususnya pada hari acara itu lumayan banyak customer atau klien dan partner yang juga menawarkan untuk bekerja sama. Dan kami harap setelah acara ini selesai, kami bisa mendapatkan partner maupun potensi-potensi pekerjaan, baik itu di Indonesia maupun di luar negeri. Kalau dari negara yang mengikuti pameran ini, khususnya yang sudah mengunjungi booth kami itu dari Polandia, dan ada juga beberapa yang dari Jerman, yang dari Singapura dan Malaysia. Untuk pameran ini, ke depannya kami harap agar lebih banyak lagi ya perusahaan-perusahaan yang mengikuti pameran ini, khususnya dari luar negeri, karena potensi pasar di Indonesia itu kan sangat sempit, khususnya untuk railway ya. Kalau untuk luar negeri, jadi kita akan bisa mengembangkan pasar railway itu sendiri tidak hanya di Indonesia gitu. Kita bisa mengembangkan pasar di luar negeri juga.
Okay, thank you, William. Let's now move on.
Silakan, Pak.
Yeah, it's time for us to enjoy the presentation from Pak Zulham. Pak Zulham is representing PT LRS Railway System, a subsidiary of PT Land Industries. His working experience is, you can see in the screen. I think the most important thing for me is to let you know that he's graduated from the Electrical Department of Institute of Technology Bandung, the best Institute of Technology and from the best department. I know in bahasa Indonesia we call it, itu sekolah orang pintar. Jadi orang elektro di ITB itu paling pintar-pintar. Nomor 2 orang sipil, Pak Sugiyadi seperti contohnya itu. Kemudian Pak mesin juga, Pak Hermanto. So we are expecting so much from the citizen of Pak Zulham. Pak Zulham siap Pak? Sudah Pak?
Baik Pak, sudah siap.
Oke, please.
Bagaimana?
Screen is yours. Ya, silakan.
Okay. Okay, let me share the screen first. Okay, good afternoon, ladies and gentlemen. It's a pleasure for me to deliver the presentation today about automatic terrain protection. My gratitude to Mr. Hermanto and Mr. Joko to allow me to deliver this presentation. Okay, we have heard from the previous presentation that we will need, we will need the automatic terrain protection, because from the previous presentation, you could see that there are so many accidents happening in the railway. One thing to make sure that it will not happen, we will have to install or deliver automatic train protection. Here, here the introduction, the railway signaling history from 1825 until now. The first is fully mechanical, and then the latest development, we are using the ATP system implementation, and the year 2000, we have implemented the modern train control. Okay. Basically, there are two types of signaling technology. That is route control. You can name it. It is the no interaction between train system with signaling system. So the train is fully independent to the signaling aspect. If the driver is overslept or violate the signal, he will maybe do a crash to the train. And the second one is train control. There is interaction between train system with the signaling system. As you can see, this is the architecture of the ETCS level 1, and this is the architecture of ETCS level 2. In ETCS level 1, there is a technology to communicate between the signaling and the train system. Here we see that there is a transponder ballast, or usually Euro ballast in Europe, and there is a antenna or radar installed on the onboard. There is also onboard controller and DMI. We will explain it later in the more detail. In this technology, it's the intermittent ATP. That is, the information of the signaling will be updated to the onboard only if the train sees or meets the transponder tag. Okay. In contrast to level 2, the communication between the train system and the signaling system is continuous. It's continuous. We are using the BTS. In Europe, maybe GSMR. In Indonesia, in LRT Jabodebek and PMS in Soekarno-Hatta SkyTrain, we use a Wi-Fi. Okay. This is the automatic train protection definition. The ATP is a safety system designed to prevent train accidents and enhance operational efficiency. That's as we see the previous presentation. Train accidents can happen from many factors. One thing that is to minimize the accidents, we can use this type of technology, that is automatic train protection. And the objective of this ATP is to ensure safe train operation by enforcing speed limits, maintaining safe distance, and providing emergency braking capabilities. The ATP technology, it can be installed based on requirements. That is, we can see for the example, for the urban transport that is a rapid movement of railway movement of train, the continuous ATP is much more preferable because it will minimize the headway so that the train can come earlier and go earlier than using the fixed block system. Okay, the benefit of ATP, as you can see here on screen, prevents overspeeding, reduce the risk of collision, enforce safety protocols. Okay, so it depends on the requirement. That if we maybe need to add requirement, so the ATP itself can be upgraded. Okay, the second one, the benefit of ATP is allows train to run at optimal speeds while maintaining safety, maximizing network capacity. Okay, this is true for the moving block system. Okay. Then the benefit of ATP is reduces delays, optimize train schedules, and minimize service disruptions. Okay, as I told earlier that there are two types of ATP system, that is continuous ATP, and next one is conditional ATP. Okay, the continuous ATP, that is the train is monitoring and being monitored continuously by the signaling system. So we can add many parameters such as the train speed, the opening the door status of the train, the platform screen door status, the signaling status, the virtual block status, and also if there's object on the track. If there maybe in the future, if the signaling system needs to check if there is a object in the track, we can add sensors, maybe camera and AI to detect, oh, there's an object that is big enough to make a train derail. Okay, that is continuous ATP. So the monitoring is real time, and there's also automatic braking, of course, and constant safety enforcement. Okay, this is the continuous ATP architecture in APMS, Automatic People Mover System, in Soekarno-Hatta Airport SkyTrain. PLRS implemented the whole signaling system for this APMS. So as you can see, there is a centralized train control here, or ATS in the name. Then there is zone controller. There's also CBI. There's also the onboard equipment here. So the zone controller is continuously monitoring the onboard system using the data communication. Here, that the zone controller continuously gives the LMA and status of the track condition. Maybe the platform screen door of the on the track is still open. The train cannot move forward, and also train cannot move inside the platform screen door if there is door open status. Okay. Here's the onboard equipment using in continuous ATP. We use in APMS. There's a DMI to monitor the signaling system. It is used in GOA1, where there is still driver controlling the train. If for GOA, upper GOA, we don't need DMI because the ATO will take over the train operation. Okay, then we have transponder tag. It is a fixed value of information. It will inform the onboard computer that we are in what kilometers and what line, maybe line A or line B. And then there is a proximity to detect that is the train is aligned with the platform screen door. And there's also tachometer to measure the speed of the train. Also the antenna to communicate between the train to the wayside equipment. Okay, this all the equipment is continuous ATP. It's just complex. It can monitor continuously to the whole train system. Then there's also conditional ATP, where the systems are activated or updated in specific situations or conditions. That is the value of the ATP system is updated once when the
Zulham, you are muted.
Muted.
Please
Hello?
unmute your speaker, your mic.
Halo, halo.
It is muted by operator. Operator jangan di mute itu Pak Zulham.
Halo. Man, dengar.
Itu obey
Suara
operator
Pak
itu.
Zulham terdengar, Pak?
Halo, tes.
Terdengar,
Operator,
Pak?
please unmute.
I've already unmuted. Okay. My friends heard my voice. My friends beside me now.
Saya bisa mendengar suara
Ya.
Pak Zulham kok.
Okay. Shall we continue or?
Yeah, it's okay now. Yeah.
Okay. Okay. So this is the conditional ATP. That is the train is not continuously monitored, and train cannot monitor the track continuously. The system is updated once the train meets the transponder tag or balis or Euro balis. Okay. Usually the balis is installed close to the signaling aspect. So this is the example of conditional ATP. Okay, the driver sees the signaling aspect, and then interlocking system through the signaling housing informs the balis. It will sends the information, the predefined data, to the onboard ATP, onboard antenna. Then the ATP itself will monitor the current information and the current status of the train, such as the train speed. If the train speed is violating the signaling, then the ATP will do braking. Emergency braking or maybe full service braking is enough. Depends on the requirement. So this is the conditional ATP is used in ATS level 1 and Japan's ATS or automatic train stop. Uniquely in Japan's ATS or maybe Korean balis that is used in Jakpro Jakarta Propolindo LRT. The balis itself use the resonant balis. Resonant balis. We will inform that later. Okay. And it is level 1. The Euro balis. There is a data transmitted through the balis to the antenna. Okay. And these are the key components of ATP. Wayside equipment. Okay. Such as the balis or maybe zone controller for the CBTC. Depends on the requirement. Then speed monitoring, there's a sensor installed on the onboard. Then onboard controller, this is the brain of the ATP system. This is the brain. It will monitor the system from the sensor and from the communication device. Then there's a communication system. It depends on the requirement. Maybe for the conditional ATP, we can only use the Euro balis, which is the information is transmitted only for certain period of data of time. I mean, and then for the CBTC or ATCS level 2, the communication system is continuously exchanging data. Then emergency braking system. Okay, this onboard controller will monitor all the wayside equipment, speed monitoring, and communication system. And if the train is violating the signal aspect or the speed limit, it will perform emergency brake. Okay, this is the example of wayside equipment and onboard antenna. This is common in Europe in ETCS and also used in Jabodebek, LRT Jabodebek. In LRT Jabodebek, we use the Euro balis. Euro balis, it transmits the data to the onboard antenna for the information received from interlocking. This one is used in LRT Jakpro. This from Korean. This balis is resonant balis. There are four resonant frequency. for each signal aspect, for red, green, yellow, and the yard mode. So if one signal is active, then the regarding frequency will be activated and it will resonate with the onboard antenna. Okay. And this one we use in APMS in Soekarno-Hatta International Airport, SkyTrain. This is transponder tag. It has a fixed value. It cannot be changed forever, the value. It will be transmitted to the transponder, the tag reader installed on board, and it will inform the CBTC on board that I have read this fixed value of number. You onboard controller process the number, so we will know what you are in what line, what kilometers, and in what line. Okay, this is the train control technology. There's PTC, CTCS, GRTC, KRTCS, CTC, and CBTC. Okay. In Indonesia, the CBTC is used in APMS and LRT Jabodebek. TCS level 1 is used in LRT Palembang. Okay. Okay, some other additional information. The ATP itself can be upgraded. Depends on the requirement. There is a GOA, grade of automation, from 1 to 4. From 0 to 4. I mean, 0 is the lowest level. It is the train is entirely controlled by the driver. Okay, it is common in Indonesia, yeah. The intercity train basically use GOA 0, so the safety of the train is on the hands of the driver. Okay, this is the table of the GOA level. In GOA 1, there is the first introduction of ATP. Okay, train operation fully monitored by the ATP. Setting train in motion, driving and stopping, door closure, and operation in event of disruption is handled by the driver. Okay. Then in GOA 2, and you can see in GOA 1, the hands of the driver is still on the panel. You can see that. And in GOA 2, you see the hands of the driver is not on the panel. There is an introduction of ATO computer. In GOA 2, it partially take over the responsibility of driver, such as driving and stopping and setting train in motion. Then in GOA 3, there is driverless train operation. There's the setting train in motion, driving and stopping, door closure, partial door closure is fully handled by the ATO, and the operation and event disruption is fully responsibility of the attendant. We don't call them driver anymore, but attendant. And GOA 4, no attendant at all in the train. Everything is taken over by the ATO. Okay. So ATP itself can be upgraded, and we can add the ATO to assist the driver during the train movement. Okay, this is the detailed explanation. You can see that later. Okay, this is the explanation. Okay, the time is okay. One. And there's a benefit and disadvantage of each GOA. So the ultimate thing is what's the requirement? Do we really need the ATO or ATP for this kind of the transport? So if we have to increase the safety, capacity, performance, basically we will use the higher level of GOA. But this advantage is also the high cost itself. Okay. And this is the ATP profile. Okay. It depends on the train characteristic and the track characteristic. Okay. This is the GOA1, the interconnection between the interlocking and the train system, as I explained previously. This is some of the devices used in the APMS. This is human interface, human machine interface. If it's still in GOA1. Okay. For the higher level GOA, we don't need this anymore. We still need this for the backup plan if the ATO devices is not working. Okay. This is the device used in the GOA1. There is a transparent data balance, fixed data balance. It's used to inform the onboard that we are in what kilometers and in what line or what area, something like that. And transparent data balance, the value is changed depends on the signaling aspect. And the LEU, line set electronic unit, is used to translate the signal aspect to the transparent data balance. Okay, this is to be used in the GOA1. So basically, for the upgraded ATP, for the upgraded GOA, we will need more devices to assist the driver. But also another consideration is the cost itself. Is it worth it or not? Okay, this device. Okay, from GOA2 until GOA4, it explains mainly about ATO. Okay. Okay, this is how to basically ATO is not basically ATO can move train for the comfort for the passenger. The ATO still consider the comfort zone for the passenger. So first we model the train, the mechanical movement of train mathematically. This is the example. If the train is given force of 1,000 Newton and something like that, this is the graphical of speed to time to speed. Okay, we model into system identification, and then the system identification calculates the transfer function for this train. After we calculate the transfer function, we get it the parameter. Then we choose the PID for the controller. Then we tune the parameter until we get the wanted value, the most comfort value, and comfort and still maintain the speed, still maintain the maximum speed, optimized speed. Okay, and this is the simulation result. Okay. Okay, this is a comparison to the first 2 and 3. This I told earlier, if we are going to deliver maximum safety to the system, maybe there is an object, very big object.
Zulham, I'm sorry to interrupt you. There are so many things to be presented. Can you make it faster? Because you've gone more than 5 minutes beyond your little time. Yeah.
Okay, Pak. Okay, I think we can do it easily. This is actually in order to increase the safety, we need to install devices based on requirement. Okay, that's what ATP and ATO is. Okay, Pak. Okay, thank you for your time. This is the end of the presentation.
Okay, thank you, Pak Zulam. It's a very enjoyable presentation. Actually, I was really forced to curtail the presentation because of the limited time we have. But apparently, it explained to us that the ATP is very helpful to implement the automation of the railway system, ranging from GO1 to GO4. And yeah, we hope you success in the future with your products, and hope you can cooperate with other entities of the railway business in Indonesia and abroad, especially the one that is coming to us later, Pak Hari Samsudin, representing the Histaco. And again, Pak Zulan, thank you very much. We'll move to the Pak Ali Fahrani. Ali, can you hear me now?
I can hear you well.
Yeah, okay. Your presentation is titled Model-Based System. I hope you can give us more understanding about how the model is working, and of course we will open the insight of the Indonesians about the existence of Histaco in Indonesia. The screen is now yours, Pak Ali, please.
Thank you so much. First of all, please let Mr. Harry to play a video about Histaco, if it is possible. After that, I continue to presentation. Is it okay?
Oh yes, it's going to be a video first.
Yes, Mr. Harry.
Warahmatullahi wabarakatuh. Thank you so much, ladies and gentlemen, for this time. It's been an honor for us to be here. Let me introduce myself. I'm Hari Samsudin, as companies from Indonesia, Histaco Indonesia, in representing as a representative from Histaco companies in Iran, which dealing in signaling, interlocking, and telecom for railway. First of all, let me say our respect to Pak Hermanto Dwiatmoko, the chairman of MASKA, and of course, Pak Joko Murdiono, representing Director General of Railway from the Ministry of Transportation of Indonesia, and Ibu Erni Basri, and of course, Pak Julham from LRS, and of course, Pak Krishna Amir Hamzah, a MASKA expert and as a moderator today afternoon. It's been an honor for us again to be here, all of our senior here, and maybe all our colleagues, partners, and friends that are following and joining this webinar. Before Mr. Ali presenting Histaco, let me present a video presentation about Histaco. Let me share my screen. Can everyone see the screen?
Yes, we can, Pak. The video has no sound.
No sound?
No sound.
How about this? Can you hear the sound?
No sound. Okay, now the sound is on.
No sound?
Just recently, the sound was on.
Hey, it's okay now. Just turn up the volume.
Signaling AFC power, units and standard import equipment. This company has been working in the field of design, manufacturing, and standardization of signaling system products since 2009 and has succeeded in localizing and manufacturing fixed line and business to go system with a wide range of signaling subsystems and products. Actions taken in this roadmap are summarized as follows. Electronic interlocking system is the most important part of signaling system with throughout option global architecture. All kinds of lane-side equipment, object controllers, including point machine driver, signal light driver, and bias controller. All types of track safety systems, especially the frequency type with the ability to send data to the train. Input-output interface equipment for lethal, non-lethal signals. Train onboard equipment along with the relevant interfaces with NTP LTO capabilities. Wireless hardware testers for configuring, testing, and troubleshooting of different parts of the modules. Different types of software simulators, including station simulation, headway simulation, and analysis, train simulator, etc. Design and implementation of signal equivalents compliant with range, parameters, and similar standard needs. The Stockholm capabilities and features are planned in modular, flexible, and scalable system and integrated into the other signaling systems. The Stockholm references and experiences about signaling inclusive projects based on all domestic products, including execution of the software extension project with the terminal line, execution of several projects in India's railway market, execution of Shira's metro line project that is ongoing, and also there are negotiating for other signaling projects in India's metro and railway field.
Well, thank you so much. And ladies and gentlemen, Mr. Ali Farahani, please.
Let me share my screen. Okay. Hello, ladies and gentlemen. Good afternoon. I hope you are well and have enjoyed from the other part of this webinar. I am Ali Farahani, technical manager of Histaco, our company. As Mr. Hali mentioned, our company operates in the field of design and production of interlocking system and also ATP systems. I'm honored to be in this webinar today. And today, I want to put some information and talk about model-based system engineering methodology for safety critical applications. What are safety critical systems, and why should we use system engineering methodology for this sort of system? And after that, we will deal with model-based system engineering as one of the best methodology used in design of safety critical systems. Well, as you know, a safety critical system is a system whose failure may lead to lose of human life or may have some serious environmental consequences. These consequences are so important that they force us to choose the best possible methods in designing these systems to reach the highest level of safety, reliability, and also availability. Exactly at this point, system engineering comes to help us. But what is system engineering? System engineering is a field of engineering management that focuses on how to design and integrate and manage complex systems like safety critical system or any other mission critical system over their life cycles. Maybe you think about why we should use system engineering methods. And we have to use these methods because system engineering help us to identify the exact stakeholder needs and tracing them to the next phase of development of our safety critical systems. And according to that, these system engineering methods help us to have top-down approach, and it helps us to improve and optimize time and cost of development. Sometimes some people think about system engineering and think that these methods maybe increase the time and cost of development, but finally, at the end, they realize that by means of system engineering, because of the high quality that you reach after using system engineering methods, the time and cost of your development definitely reduce, and you can optimize it. Furthermore, you can improve your reliability, can determine the exact role of everyone in your team, and you can have better team working and better evaluation of your project. And at the end, you can have better change management if you use system engineering methodology. But what do I mean when I said methodology? I mean some product development cycle that determine who should perform what tasks at what time. And there are different type of methodology for system development. And the first category of this system methodology called spiral. And these methods are more focused on continuous improvement of system in several system cycles. That are some methods like agile methodology, but they are not usually used in development of safety critical systems, because in these systems, the output of each phase of the system development must be definitely specified before. And for this reason, waterfall methods were developed that start from requirement analysis and continue with design implementation and the another phase of development of systems. However, in order to create a better cross communication between development phase of a system and at the same time the are very popular in development of safety systems and mentioned in many standards like EN 50126 for being compatible with safety critical standards. This methodology is very useful for being compatible with this sort of standards. In these methods, we have some phases for developing new idea of our new system. In the left side of V model, for example, some requirement phases, some architecture phases, some design phases. And the another side, we have some test and integration and acceptance phases on the right side, I mean. And also each of these phases has some horizontal connection with corresponding phase on the other side. Usually, nowadays, V model is very useful for developing safety critical systems. But today, I want to focus on model-based system engineering. And what is model-based system engineering? It is some technical approach of system engineering that focus on creating and exploiting domains model instead of traditional document for information exchange. I mean that in this approach, we should use some sort of a standard diagram such as UML or CSML diagrams to describe and model and design different parts of our system in such a way that this diagram have the ability to turn into the more detailed design or even implement the system automatically. you know that we have different type of diagrams, like behavioral diagrams, structural diagrams, or parametric or requirements diagrams. All of these diagrams is a mutual literature for all of engineering all over the world. And in model-based system engineering approach, we should use these type of diagrams for developing our systems and documenting our systems instead of some traditional documentation. So why should we use a model-based approach? First of all, because reduction of human errors. Obviously, using this type of diagrams and using some tools for automation implementation, human errors may be reduced, and we can improve implementation time because we are using some modeling language that are very close to implementation. Also, this approach improve our safety and quality of final product, and we can improve our documentation, because by using this approach, documentation is not just for documenting at the end of every phase. We use modeling for any phase of our designing system, and regarding that, we can improve our documentation by means of mutual understanding about mutual language that is standard diagrams. And after that, we can improve our teamwork, because all of the teammates have an understanding about these diagrams, and we can improve the process of information exchange and change management. And at the end, by means of this advantage, we have the possibility of outsourcing some implementation phase of our product to another third party. And because of this advantage, we have to use model-based system engineering for developing our safety critical systems. But as I said before, one of the main tools for model-based system engineering is SysML language. But what is SysML? SysML is a general-purpose graphical modeling language. It stands for System Modeling Language, for specifying, analyzing, designing, and verifying complex systems that may include hardware, software, information, or any other parts of system. And as you can see in this diagram, system is very similar to UML, but UML, the focus in UML is more on the software aspect of the system, while SysML, in SysML, the focus is on all aspects, both hardware point of view and software point of your system. So being familiar with SysML for developing a system based on model-based system engineering is very important. And after that, I said before that another important tool for help us in model-based system approach are tools that can automatically take us from model to implementation, like some autocode generation tools in field of software. And here I want to mention some of these tools very briefly, and the big companies that use them, and give example. The first is MATLAB. You all know MATLAB Simulink, but maybe you not know that in 2017, it was informed that it used MATLAB Simulink and model-based approach in design of the fuel management system of the Airbus A380. As mentioned in this article, you can see the trend of using system engineering approach in design of Airbus products. You can see that in these diagrams, every year Airbus make a better decision for using a higher level of model-based design in designing their new products. And in this diagram, you can see the life and it represents to us that using system engineering, and in particular using model-based system engineering, it's very important for developing safety critical applications and safety critical systems. The next tools that I want to introduce you is the IR system. IR is one of the famous compiler in the field of embedded programming, but few people know that IR has developed an ecosystem through which you can describe your software and based on system diagrams such as essay chart and convert it to code. Based on this advantage of IR, some famous companies such as Schneider Electric and Science Labs informed and announced that they have used IR system in designing of their product. And the last tools that I want to introduce is IBM Rational Softwares. These tools cover all aspects of model-based approach, and IBM claimed that based on statistics, using these tools have saved a lot of money and time in projects for companies. Nowadays, about 70% of companies use IBM Rational Software in the field of embedded software programming and system modeling. And this is why IBM has designed and present its own methodology based on V model. The name of this methodology is IBM Harmony, which is very useful in the designing of embedded and mission critical systems. And right now, we are using some kind of this methodology in designing and developing our systems, our interlocking system and ATP systems, to make sure that we are fully compatible with the safety standards, and also we are fully compatible with the model-based system engineering approach that is very critical and important for developing some mission critical systems. At the end, I must say that based on the advantage of model-based approach, it is very, very necessary to use this approach in the design of safety critical systems, and therefore model-based safety engineering approach ideally integrate with the model-based system engineering and provide remotely. That being said, in general, the introduction of additional effort and investment must therefore be carefully planned. And it is very necessary to having this approach for designing safety critical systems. And I think there is very topics behind of this model-based system and model-based safety engineering that we can talk furthermore after this meeting, and I would be happy to answer if you have any question. Thank you for your attention.
Thank you, Mr. Ali Farahani. Farahani, I always miss you with the Farahani. It's Farahani. I remember the one named Ali that is very popular here in Indonesia, also from Iran. It's Ali Dai. And of course, Ali Khamenei.
Yes.
But Ali Dai is a
Yes,
very popular
yes.
one. Yeah.
They are one of the most famous people in Iran.
Yeah. Okay. Ali, to tell you frankly that Pak Hari, his presentation is very complicated one for me. That is not based on control system in my education background. But the empirical fact told us that the system have already proven as proven its ability and reliability in support any kind of engineering system in the world, like in IBM and other part of the popular engineering in Indonesia. I am actually always reading the presentation using my iPad. You have sent your presentation day before. I read it last night. I read it again while you are presenting today. To tell you frankly, I think I need at least 3 or 4 times more to read it again to understand your presentation. But anyway, it's very interesting one. Maybe later in the question and answer, we'll find something more. And Pak Hari, after he joined Masca later, he will be able to socialize these things more in Indonesian railway system. Thank you very much anyway. We'll move to the question and answers. I have so many question rates here. Bo Leon, can we continue to the question and answer session? But
Yes, please.
before that, I have to remind you that we have this attendee list. You have to fill the form to get your materials and your presentation. Is that true?
Yeah.
Okay. Bulion, yeah. Okay. Where's the question here? The questions here coming from so many anonymous here. I want to read the question for Ibu Ernie first. From Miss Wari, Malaysia. Ibu Ernie, according your authority data, how serious is the impact of the natural disaster like earthquake, flood, landslide? We just experienced it yesterday or 2 days ago, I think, landslide in Bogor. That's for Bu Ernie. Keep the question first. You'll answer it later. And then for parts of for Pak Hermanto. Okay, the question is one of the factor, and the first one can be the risk assessment done during the design study RAMS. He's asking about RAMS. And
Pak Krishna, interupsi sebentar.
Yes.
May I have one moment? I would like to show one video.
Okay. Just keep the
Okay, sorry about this.
Yeah, we all both forgot it. Yeah.
Oke, silakan panitia.
Okay, please.
All right, back to moderator, please.
Okay, I'm continuing the question. Second question for Bu Ernie regarding the GOA3 in Jabodetabek, which need more safety intention is coming from ABB, from Pak Dedi. Pak Irawan, are you there? Yeah, I can see you before. From safety point of view, how regulator and operator facing this trend? I mean, Pak Dedi is asking about questioning about the readiness of the regulator and the operator to operate the GOA3 in RTJBEC. It's a very easy question actually for Ernie because it's involved from before. And then for, I'm looking for a question for Pak, what's this? Pak Zulham. Pak Zulham, there's a question for you. Oh, there's no question yet for Pak Zulham, I think. And of course, there's a question for Pak Ali. I think it happens just like to me too. They don't understand what you are presenting, the detail. I mean, they know the empirical facts. I think they believe in its reliability and its ability, but I don't think they dare to ask a question for you. It's like in the in the university class, you know, sometimes you don't dare to raise question to the lecturer, because if you ask a question, we might seem so silly. Anyway,
Yes.
Okay, if you
There
want
is two
to add something
possibilities.
later,
Maybe it
yeah.
was very clear, or maybe it was not clear.
Okay.
Zero or
Anyway,
one.
you'll have time to explain, maybe elaborate it more about your presentation before after the two speakers answer the question. Please say Bu Erni first, Pak. After that, Pak Hermanto. Bu Erni, silakan.
Okay, thank you, Mr. Krishna. Actually, I've already answered by message.
Oh, okay. But maybe
Yes.
only for the this question, but not public.
Yes, so for landsliding and flooding, so we have a specific area for South Sumatra and West Java. West Java is some of there are sliding, but we have protects, and then some of our inspections shows the infrastructure still not impact for operations. We have a mitigate, and then there is no accident causing the flooding or landslide. So for GOIT in LRT Jabodebek, we still have operator and regulator agree about ISA. We have received from infrastructure and also rolling stock ISA of acceptance, and then currently we still have to check the processing and confirm with them, visit our team to make sure issue the safety recommendation before we issue the operational permit.
Okay. Yeah. So Alhamdulillah, Pak Ali, you have known that so far in Indonesia, the natural disaster never caused an accident. It only caused disturbance to the railway operation. But Alhamdulillah, because we always pray, we have dua every time, so there is no accident caused by the natural disaster, like flood or earthquake. So many earthquakes in Indonesia, so many flood, and also even landsliding. But Alhamdulillah, it caused no accident. Because Bu Erni always dua every day. Yeah, okay. Okay, Pak Hermanto, are you still around? Pak Hermanto, I think he's giving a lecture, but I think he already answered the question directly to the one that is question. Mr. Ali, you want to add something to make more understanding to your audience? You have 2 minutes.
And 2 minutes. Okay. If I want to put some more information in 2 minutes, I want to say that if we want to develop a system in safety critical aspects, for example, in this railway industry, we should be compliant with some safety standards, for example, Senelec 50126. And when you observe these standards, first of all, you face with some life cycle that standards force you to follow this life cycle in developing your new system. Exact at this point, system engineering comes to help us, because that life cycle that mentioned in standards is not practical. It's not. It's just something on the paper. But system engineering help us to make it more clear and make it more practical, and it help us to develop our system based on a standard life cycle that start from requirement analysis and continue with architecture and design and implementation and testing. But every of these phases has many details points that system engineering help us to don't miss these detail points and make a reliable and safe prototype at the end of the developing phases. This is the main advantage of system engineering. And if we want to use a better methodology, we should move into model-based system engineering, because model-based system engineering is very mutual understanding and has very mutual understanding points, and is very fast methodology for developing some mission critical systems. This was the concept behind of my presentation, but there is many detailed points we can discuss about it in Railway Expo or any other place that you want.
Thank you. I was just wondering, what did you eat, you Iranians? Because I have so many colleagues mates also when I studied in Europe. You are all very good in engineering and mathematics, Hari. I don't know what did they eat. They eat only pusus kebab. I tried to eat kebab also, but I was never able to catch them, especially in math and engineering. Okay, anyway. I hope you can come to the Indonesian Railway Conference next August to give us more understanding about the system. And I will be very happy to be your moderator again later, so we can study directly from you. Pak Hari, want to add something? You can use Indonesia because people are waiting.
Yeah, thank you so much. But I believe that Mr. Ali will be here this upcoming August into the exhibitions, and furthermore, of course, we will have additional meeting with Maska together with you, of course, and I will discuss in and out, all out about the railway system and technology in Indonesia and how the development will do, how we want to do, what is our target, and how do we develop and gather local components. Thank you so much.
Okay, thank you for your kindness to be one of the speaker in the railway conference next August. Pak Zulham, we still have 5 minutes. Do you want to add something?
Okay.
There's no question for you, but I have one. Tell us about the experience from you implementing the ATP in some part in IPMS and LT Palembang. Is there any problem or any experience in the failure of it?
Okay, I myself and the team, we developed the CBT system in IPMS, Soekarno-Hatta International Airport SkyTrain. This is the first CBTC implemented in Indonesia. And the second one is the LRT Jabodebek. It's provided by us too, but we act as a system integrator. But for the whole system, we develop CBTC for the APMS. We develop from A to Z. We study the CBTC standard. We also study the EN safety standard, the EN 50126, 50128, 50129. We studied everything, and in the end, the system is certified by the BPPT, now BRIN, and it has certified by BRIN. Sekarang sudah layak pakai, Pak. Sudah layak pakai. Worthiness-nya sudah dapat.
Okay, good. Is there any failure your experience during implementing in APMS and LRT Palembang?
The failure, I think, is only minor. Minor, I think, not so much failure, because after mainly in communication device. At first time we implemented the communication device, there is interference from other device, and then we install the filter for the antenna.
Well, for the communication, what system are you using? SCADA or?
Oh no, Wi-Fi for the
Wi-Fi.
CBTC.
Okay.
Wi-Fi, because
okay,
there's another the same frequency for the frequency.
Good
device.
enough lah. Compared to you're not using Bluetooth, right?
No, Bluetooth.
You're using Bluetooth.
Because
You give me
GSMR
very,
is still not
very
licensed
low.
for the railway in Indonesia, and we still need
Okay.
the certification from the Menkominfo for GSMR.
Okay, yeah. Bu Erni, are you still there? Bu Erni? There is a new question for Bu Erni. Oh, she left already, I think, because it's already Asar here in Indonesia. Bu Leon, I think my job is done. I hope you all enjoy the discussions. And if you still want to know more about things discussed, please just come in the next International Railway Conference, Indonesian Railway Conference next August. And again, don't forget to fill the form of attendee list for you to get the materials and the certificate. I return the screen to Bu Leon. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih banyak Pak Krisna untuk sesi yang menarik. Ladies and gentlemen, we would present Mr. Bakili, the Director of Game Indonesia, to deliver some remarks. Please stay with us to get the information and current update. Pak Baki, silahkan Pak.
Yeah, good afternoon, everybody. Good afternoon, our speakers. Good afternoon, Pak Dirjen, and all speakers. Okay, thank you for all the audience to join with us in the Indonesia Railway Virtual Conference. This is our second edition for this year. So our next virtual conference will be talking about rail green technology, green rail. So actually, we have the information from the Pak Dirjen, Director General for Ministry of Industry and Ministry of the Transport. Indonesia will have a program to reach the zero emission by 2060. So all the transportation will be switched to the zero emission. So one of the government program in the future is a green rail transport, so including for rail transportation. So we hope in the next sessions, our exhibitors will be talking about more details about the green rail technology innovation. So we hope you can join with us again in the next session, especially for our exhibitions this year, Railway Indonesia 2023. Will present 100 more exhibitors from the overall 20 countries. So this is a good chance for all company in here, all rail transportations suppliers, manufacturers, and also the operators. We have a good opportunity to build a good network through this exhibition. So I believe the exhibition will be very useful, not only for the our exhibitors, but for our audience, for visitors. The visitor can have a lot of the things to know, to get information from the our exhibitors railway system. So we hope you, all of you, our audience can join us again in our next railway webinar on this next August. The date will be confirmed, will be advised again. Thank you for all of you. So we have a good day today. Thank you.
Terima kasih banyak Pak Baki. Ladies and gentlemen, now we are presenting our gratitude towards all speakers and moderator for their participations by handing out virtual certificates. First appreciation is for Ibu Erni Basri, the Director of Railway Safety from the Ministry of Transportation, Republic of Indonesia. Next, the certificate will be given out to Bapak Zulham from PT Land Railway System. And the next one is for Mr. Ali Farahani from Histako, which is one of our exhibitors. And last certificate is presented to our moderator, Pak Krisna Amir Hamzah. Thank you to all speakers and moderator of your presence at today's virtual conference. Ladies and gentlemen, now I would like to remind you all, for those who like to have the presentation materials or certificate, please access the link which is displayed on your screen. You may take a screenshot. Bagi para peserta hari ini, jika Anda menginginkan sertifikat keikutsertaan atau materi presentasi, silakan mengakses tautan yang tercantum pada layar kaca Anda. Kami akan siap mengirimkannya sesuai dengan permintaan Anda. Through this opportunity, we like to deliver our gratitude to Ministry of Transportation, the Republic of Indonesia, especially for the Directorate General of Railways. Our gratitude is also addressed to PT Land Railway Systems, Histako, and special thanks to Maska for the support. Ladies and gentlemen, today's webinar has ended. Please take note that Railway Tech Indonesia exhibition and Indonesia Railway Conference will be held from 23rd to 25th of August 2023. This year, Indonesia Railway Conference will present a special theme that is Indonesia's rail projects, trends, opportunities, and challenges. We would present a great conference regarding the updated technology, opportunities and challenges of Indonesia rail industry. If you are interested in joining this conference, please contact our team. And one more thing, please. We will hold the next virtual conference at the beginning of August, which is before the exhibition take place. The theme is Green Rail Technology Innovation. On behalf of Maska and Game Indonesia, thank you to all speakers, moderator, and attendees for being with us today. I'm Liun from Game Indonesia. Good afternoon. Thank you to all speakers.
Thank you so much.
Bye-bye.
Have a great day ahead. Bye-bye.
Thank you Pak Ali, Pak
Thank you
Johan,
so
Bu
much.
Erni.
Thank you, Ali. Bu Erni, thank you very much.
Thank you, bye-bye.
Ya,
Thank you.
Pak Joko ketukar sama Pak Hermanto itu tulisannya.
Ya.
Terima kasih ya. Sampai jumpa lagi. Assalamualaikum. Waalaikumsalam. Ya.
Halo, perkenalkan saya Bintang Ramadan. Saya dari PT Land Railway System, berkedudukan di Bandung, Jawa Barat. Kami adalah salah satu anak perusahaan BUMN, yaitu PT Land Industri Persero yang saat ini menjadi holding perusahaan Defend ID. Tujuan utama kami mengikuti pameran ini yaitu agar kami bisa mendapatkan pasar baru. Dan kalau dilihat dari pengalaman-pengalaman sebelumnya, pameran ini juga memunculkan potensi-potensi supplier dan vendor yang dapat bekerja sama agar nantinya kami dapat mengembangkan sistem sendiri bekerja sama dengan partner-partner yang ada di Railway Tech ini sendiri.
This is my first time to come to this exhibition, and I know this is the biggest railway exhibition in Indonesia. And it's my pleasure to attend this exhibition. And CRRC, as the biggest exhibitor in railway industry in Indonesia, we are very pleased to be invited to this exhibition. And we are the supplier of Jakarta Bandung project. And now almost 90% of the project has already been finished. And we have already we have already received many visitors from relevant industry, and also to supply the service and also the maintenance also.
Nama saya Dedi Irawan, saya Division Manager Motion Traction dari PT ABB Sakti Industri. ABB adalah perusahaan multinasional teknologi, worldwide company, bergerak di bidang elektrifikasi, automation, motion, dan robotics. Khusus untuk Railway Tech ini, kami memperkenalkan portfolio kami dari sisi traction, yaitu propulsi system, karena kan di pameran ini berkumpul semua pemain-pemain kereta api. Jadi ini ajang yang betul-betul bagus. 3 hari ini sangat efektif. Kita saling kenal semua, produk kita lebih dikenal, dan kami juga mengenal produk-produk yang lainnya juga, operator-operator kereta api di Indonesia.
Nama saya Restoiko Prabowo, kami dari PT Wijaya Karya Beton Tbk. Kami adalah industri manufaktur yang bergerak di bidang engineering, procurement, and instalasi. Untuk pasar kita adalah di bagian manufaktur. Untuk di industri Indonesia yaitu kita suplai beton pracetak. Tujuan kami yang utama yaitu memperkenalkan Wika Beton di industri perkeretaapian di Indonesia. Yang sebelumnya kita sudah ada pengalaman dan kita ingin menunjukkan lagi di dunia transportasi ini.
My name is Amir Junaidi. I'm the International Sales Director of the company TrekTech and Management Board Member. Company TrekTech is a Polish-German company producing in the railway business railway turnouts, as well as concrete sleepers and wooden sleepers, as well as fastening. Our production facilities are located in Poland, 6 as well as in Germany. And our intention is to do international sales. We serve transit authorities and railway organizations worldwide. We sell today to more than 40 countries, from very west, from Vancouver, Canada, to Asia. We have references in Malaysia, in Philippines, and from north, from the very north of Sweden up to south to Africa. And we know how important the Indonesian market is, which is very much growing. We see the potential and the big railway projects that are in the pipeline, and we are very eager to step into this market. Our intention is very important for us, meeting all potential customers. We had the chance to speak to construction companies who are building these railway lines, as well as potential partners with whom we can set up cooperations. So this exhibition is very valuable for us.